Myself, Professor Ashish Chandak, welcomes you in Quick Engineering. The topic of today's video is construction of push-down automata. So the question is, design a push-down automata for accepting a language L is equal to A raised to n, B raised to 2n, where n is greater than equal to 1. So in this subject, if you see here, B is equal to twice of A. So if value of n is 1, then string is ABB. If value of n is 2, then string is AA 4 times B. Then if value of n is 3, then it is triple A 6 times B. So B is equal to 2A. Now in this question, in PDA, we can insert some symbol, we can do the push operation, pop operation and peep operation. So in this question, since B is equal to 2A, we have to insert two symbol into the stack or two plates into the stack for 1A, and we have to remove one plate from the stack for B. Means for A, so for A I will use red plate. Now I will insert two red plate. I will insert two red plate for A and I will pop only one red plate for B. So this is the logic for this question. So I will trace it here. Now, so let us see the logic and then I will write the transition for this PDA. So if the input symbol is A and then for A I will insert two red plate. Okay, so stack pointer will be here. This is SP. SP means stack pointer. Then for next A, I will again insert two red plate. So stack pointer will become here. So this is the logic. And then if I found B, so if the head is on B, then remove the red plate. Okay, so stack pointer will also go down. Then for again next B, stack point make this red plate null, and then for next stack pointer we make this red plate null or remove the red plate. Then for next pointer we remove this red plate, and then there is epsilon. So for epsilon remove this z. So at the end, if you will find the stack is empty, hence the string is accepted. So in push down automata, when the string is accepted, when there is no more symbol left in the stack, then you can say that the string is accepted. So this is the logic. Now I will write the transition for this push down automata. So I will again trace the logic, at the same time I will write the transition. So initially the pointer will point to A, so I will write Q0 A Z0. So Q0 is the state, A is the input symbol, Z0 is the initial stack symbol. So we have to insert two red plates. So I will write here Q0 RR Z0. Now why RR Z0? Because we are inserting two red plates. So what will happen in the stack? Two red plate will be inserted. So this is first transition, then Q0. This is next state. Okay. So next state will become current state here. Then when the state will get changed, we will change the state only when the input symbol gets changed. So Q0 is the now Q0 is the state, A is the input symbol. Now the stack pointer is R. Stack pointer is R, so I will write here R is equal to Q0 RR triple R. So I will write triple R because again we have inserted two red plates, and then previously there is also R, so there will be triple R. Now the head will be point to B, so this is the next state become current state. B stack top is R. Now whenever we encounter the B, we have to remove the B, so I will write Q1 epsilon. Now why there is Q1 epsilon? Because input symbol is changed. Input symbol is changed, so that's why I change the state. So this is next state. Next state become current state, and then R Q1 BR is equal to क्या होगा? What is the Q1 BR? Q1 BR again we have to remove it. So it is Q1 epsilon. It is number 4. So again this red plate will be removed. Now for next B, so for next B again Q1 BR, because Q1 will be the next state here become current state, then B is the uh, tape symbol and R is the red plate. So R is the red plate here. So it will be again Q1 epsilon, since the input is not changed. So if you compare this Q1 BR is equal to Q1 epsilon, what will happen? These are the same. So do not write the transition again and again. So this transition is applicable to all the B. Now at the end you will find there is epsilon. So again we have to write Q1 epsilon. Now all the B's are removed through transition number 4. So stack top becomes Z0. Z0 will become the stack top. So it will be Q2 epsilon. So why Q2 epsilon? The reason is input symbol is change. Input symbol is change. So these are the transitions for the push down automata. Now I will trace this transition so that you can better understand how this transition are working. So initial state is Q0 okay. So I will start with Q0, then double A 4 times B, and then initial stack symbol is Z0. Now how to apply the transition? Q0 state input symbol is A, Z0 is the stack top symbol. So what is the rule? Rule is Q0 triple R Z0. So I will write Q0 A 4 times B double R Z0. So this is rule number 1. Then Q0 is the state, input symbol is A, stack top is R here. So rule is we will apply rule number 2. So it will be Q0 4 times B, then 4 times RR Z0. Previous 2 symbol and next 2 symbol, so that's why 4 times R. Now Q0 BR. So if you look here, Q0 BR, it is Q1 epsilon. So Q0 BR, we have to take the first symbol. Okay. So I will apply rule number 3. So it will be Q1 triple B triple R Z0. So now I will go to again I will apply rule number 4 now, because the state is Q1. So it will be Q1 double B double R Z0. Now I will again this rule will be applied Q1 BR Q1 BR. So again rule number 4. So Q1 B R Z0. Again then rule number 4 will be applied. So it will be again Q1 epsilon Z0. Okay, so Q1 epsilon Z0, I will apply rule number 5. So I will write here rule 5. So it will be Q2 epsilon. Okay, so the Z0 is also removed. Hence the string is stack is empty. Hence we can say that the string is accepted. So this is how you have to write the transition and you have to validate the string in push down automata. So that's it for today's session. If you like the video, then please subscribe, like and share. Thank you.